అక్కడ ఒక కాలు పెట్టిన ఇబ్బంది ఉంది. ఇట్లా పెట్టుకోవద్దా, ఇది కొంచెం వాళ్ళు తగ్గుతుంది. ఇది ఓకేనా? మొబైల్ ఏం వద్దులే కానీ ఎట్లా అని చెప్పి వస్తుంది. చెక్ చేద్దాం. నువ్వు వెళ్ళి యూట్యూబ్ ఓపెన్ చేయి. ఇంత నువ్వు మాట్లాడుతూ స్టార్ట్ చేయి. Good afternoon everyone. A warm welcome to Srinivasa Ramanujan Institute of Technology. Thank you for giving this opportunity to conduct a workshop on Internet of Things. So I'm thankful for the Principal Balakrishna sir and Banu Prakash coordinator sir and convener Ravichandra sir. So everyone, shall I start the session? So myself, I'm Janki from Amirpet, Hyderabad branch. I'm working in Pantech since 3 years. So we offer a wide range of workshops on different domains like artificial intelligence, machine learning, IoT. As well as we also support your creative ideas on your projects. So I hope everyone joined. So I'm starting this session. So today our topic is about the Internet of Things. So today we can learn some basics of IoT and its applications. So when the Internet of Things were invented, this is the revolution of the Internet of Things. Like the first revolution was started in 1969 to 1995 by Internet of Boffins. So these are the different types of stages, revolutions, but day by day how the Internet was developed. So these are the different types of stages how the Internet of Things was developed, but year by year. So in 1969 to 1995 there is the Internet of Boffins. In 1995 to 2000 there is the Internet of Bricks. So these are the masses and mobile networking, how the networking like 1G, 2G, like this we are using updated 5G and 4Gs. So Internet of Creation is a wide World Wide Web. So sharing the user-friendly information in networking system is began to spread and become very speed. So why internet? How we use internet? So wherever we go, we want to know some information. So whatever, however it may be, everyone use internet for different purposes. You can use anytime, anywhere. Anyone can use it. Is a open source protocol for education purpose. Whatever it may be, we just simply go to internet. From any device, any network also we can go to internet. So it is easily accessible. We can know some knowledge, whatever, for entertainment purpose, whatever it may be, we choose internet at any time. So in IoT is the developer version of this year. Like, so generally what is internet? So normally internet is no one's owns it, it's everyone's. There is no formal management organization for it. So it was originally developed for the Department of Defense. So in military purposes, army, defense systems, defense services, we use this internet. For that purpose, it was developed. For terrorist attacks, all this wartime, we developed this internet. So to access the internet from some existing network, to access the internet from any network you have to access, you have to pay some small registration fees. For any buying any protocols to certain standards based on TCP or IP protocols, we have to pay some registration fees for that. Buying in networks. So history of this in IoT. The term IoT, Internet of Things, was first introduced by the Kevin Aston in 1999. So generally, what is IoT? Anybody? In your own terms, what is IoT? What do you know about it? So Internet of Things is nothing but dealing with the networkings. So we exchange the data between the two devices. So exchanging of data between sending and receiving the data between the two devices without the help of humans. There is a machine to machine communication. So it is a networking between some physical objects and things. Whatever the devices is a Bluetooth, whatever like Zigbee, LoRa module, all this Internet of Things. There is a communication between the two devices, wireless transmission, like vehicles, buildings, and other items which are related to embedded electronics. Some sensors we store the data from the sensors, some database for network connectivities. Some objects to collect the data and exchange the data between the two devices. We use this IoT. It's just a combination of some networking. It works with the physical objects. Physical object, electronics, some sensors, all this network connectivity. It works with some networks. Okay. So in single line, we can see that IoT is wherever you go, anything, anywhere, we use it. In our daily life, wherever you go, it holds with IoT. In gadgets, frameworks, some home automation systems, using all the home automation, you controlling Alexa, Amazon Alexa. All these are related IoT only. Some RFID tags for tracking the location. Some mechanization, some utilization of empowers, all these gadgets working, some field hardware, some dealing with some physical components. Wherever you go, all the applications are related to IoT. So in single word, you can say that there is a reference of machine to machine communication. So it's a Skynet or an Internet of everything. All the data it has is a machine to machine communication. In IoT is used in machine learning and AI. So this concept about how IoT is used in schools. So smart Internet of Things in schools. How we can improve the IoT system in the schools. So personalized learning with adaptive e-textbooks. So we can provide the students e-textbooks, online learning. Like you have an e-pod, some e-audiobooks also have an idea. So like this all things you can comes under IoT. Some exchanging, some collaborations, some international collaborations, some meetings in online testings. So students has as their own devices, textbooks and notebooks. We can develop IoT in the schools in this way. So video files, this all the school related to schools like lectures, recording, lab experiments. So we also have some idea of some apps, right? Like Byju's. Like that, we have some online learning apps. Digital platforms like Vedantu, Udemy, all these different types of platforms we have. This all comes under IoT. Some robot cleaning, without the help of the humans, some robot cleaning in the schools. Now sensor technology like biometric attendance, surveillance and security cameras, like monitoring the students' performance in class as well as wherever you go, some surveillance security cameras will be provided. Is there. Wi-Fi sensors. So what a Wi-Fi sensors logs means we can control in our own way by using Wi-Fi based, controlling the sensors and automatically monitoring the data of the sensor by using this Wi-Fi. We can entrance text, classroom, doors also. So in sensors in parking, IoT and driver ways. In parking means it has some on online IoT only we can control the where the bus should be parked. Smart parking you can say. So already we have to register in smart parking using IoT. How it is used, like you can use this machine learning technique, IoT with machine learning. So we already online have to register that parking. So smart parking systems. As well as we use the sensors for students like buses, the driver health also we can predict. For monitoring the health of the driver, who is driving the bus. So track the buses to verify the passengers or students. As well as air quality and surroundings, air quality in the surroundings of the school to monitor the school environment. This is related to school. I mean, whatever the requirements in the school. Some attendance tracking, biometric system use for wearable athletics, sports also use IoT. These all are the advantages of IoT in schools. So this is a literature review of IoT, like year by year, what was developed in this year, in which year, like every second there are 127 new IoT devices connected to the web for every second. So during 2020, as per the previous year, 2 years back, like some installations of 31 billion IoT devices were found. So we can predict, like in 2020 we have 31 billion of IoT devices. By 2025 we can expect 152 to 200 IoT devices will connect every minute by 2025. So we can predict the future of this by using the IoT data. So out of 10, 7 out of 10 everyone own an IoT device. So out of 3 out of 4 people are planning to purchase an IoT device in next 12 months. So every consumer wants to own IoT devices. So everyone was, the problem was they are very concerned about the security and privacy. They are not aware about the security and privacy. That's the lack of buying the IoT. So whereas 81% of people are worried about their personal information is leaked. So they are about the privacies. So in other ways, some they are worried about some concern about the hackers. Some they are controlling the device, using it in a committing crime. Some crime purpose also, some people are worried to buy the IoT devices. In hackers, like hackers are gaining the access to personal information. Whatever the IoT using now, they're worried about the personal information will be hacked. These are the different types of reasons. 3 out of 4 people are not sure to buy the IoT devices, and they are monitored without the knowledge or consent. Some people have no idea about the IoTs. So these are the literature review according to the 2020 year. So these are the IoT applications. So IoT is used in all the applications like healthcare, infrastructure, industrial, commercial purpose, smart cities, and environmental. So healthcare is like predicting the in healthcare we have different applications like hospital management system. So in healthcare we are using the monitoring for the like hospital management purpose. Also we can use IoT, like how many people are there in hospital, member attendance purpose we use healthcare systems, as well as smart health system like using some like we have different applications, pulse sensors you in healthcare purpose, monitoring your own health. uh, in COVID-19 situation, we always not go to hospitals. There is a quarantine system. We are maintaining social distance, so we cannot approach the people. We cannot approach the hospitals every time. Whenever you feel sick we cannot always go to the hospitals. To reduce this type of applications, we can use IoT, like some smart health monitoring system. Like we can test our own health by using some sensors, pulse sensor and DHT level sensor, temperature monitoring. At our home only we can know our health based on our using some pulse sensors, SpO2 different. So we use these healthcare sensors, and by knowing our health, we can directly contact the doctor without wasting the time. In environmental like weather forecasting, some smart farming, smart agricultures, any climatic changes in the any weather reports. For this purpose we use IoT application. So whenever there is a change in the temperature and humidity, so we can predict the future disasters of weather, like there is any floods occurring, rainfall predicting, temperature changes, or any disasters may happen, earthquakes, tsunamis, all these different environmental disasters we can predict by using IoT. So smart farming. In smart farming system, we can take an example of irrigation, drip irrigation. So in drip irrigation, like there is a lot of water usage in a farming. So there is a lot of water scarcity in our India. Lot of water. We need more requirement of water. To save the water, whenever plant require the water, then automatically it will be on. Like using some IoT applications, some smart gadgets like. So whenever the water is required, then only the water we use some soil sensor, moisture sensor in the smart farming. So whenever the soil is dry, automatically it will pump the water to the plants. So we can save the water by this in the irrigation system. Smart agricultures. In this agriculture, we can predict the crop quality. We can know the quality of the crop, and we can how to develop the agriculture system by using this IoT and some other embedded systems, combining this embedded system with IoT. Some climatic changes in the monitor. Okay, in smart cities. In smart cities, like in smart home system, like Amazon Alexa, you're controlling your home, like a switch on, switch in the light, some change in the color of the bulb. So we have some smart bulb we have here, right? Like we can change the color of the bulb according to our mood, like light color, dark dim color, like that different types of as our own mood. We can change the color of the bulb, some using smart bulb technologies in smart homes, okay, in smart buildings, some urban computing. So in urban areas, like in traffic monitoring, like for control traffic monitoring, for without the help of the traffic police, we can automatically monitor the traffic system. We can observe, right, like for the number will be displayed red, red, orange, green. So all this automatically monitored without the help of the traffic man. And in some security and emergencies, use this IoT. Some encryption and decryption of data, wireless communication purposes. We for sending the data in security and emergency situations, we use this IoT. Some commercial purpose. Commercial means like some retail, these shopping sites we have observed, like Amazon, Flipkart. All this commercial purpose, we use IoT in shopping system. In industrials, in industries also, some there is a, you have to industry monitor the industries in gas line, some leakages in the industries which will affect the workers. Any gas leakage of detection, any gas leakage also, it will affect the industries as well. If any like any poisonous gases are detected in the industries, to detect that gases also use this IoT to monitor that sensor values. In real-time performance also, energy save efficiencies, infrastructures, we use IoT application. So there is a, whatever in which field you take, there is a lot of IoT applications. So this is about how this IoT is applicable in healthcare. So we use some smart sensors. Like we have some sensors like ECG, some pulse sensor to monitor the heart rate, some DHT levels, and any temperature monitoring, DHT level. So whatever the smart sensors you take now for health caring, that sensors are connected to the some processes that is uploaded to the cloud. This IoT is a cloud system. So this the data whatever is collected from the sensors is uploaded to the cloud, and we can get a remote. We can check that from the smart device, from our own and mobiles. We can check the data. Whatever, we can monitor the sensor values. So IoT applications in smart cities. This is about the smart parking system. As an image you can see, there is a proper order of parking the vehicles in a order, in a systematic way. So it can avoid the collision of vehicles and traffic in the shopping malls, in traffic system, wherever it may be. Anywhere you go, you can, smart parking is used to, it will be already smart way used to avoid the vehicle collisions and traffic. How this smart city, smart parking will work, like some sensors were installed at all the parking spots. Wherever you park the vehicle, already there will be some sensors will be installed around the city. So the sensors will pass the, wherever the vehicle will go for the spot, so they will automatically spot to the cloud. The sensor will collect the data of the vehicle and will upload to the cloud how many vehicles are parked. So any number of applications that can consume the data. And we can, on map also we will get the option, like for drivers, where is the shortest route to an open spot. Like in smart parking system, mobile only you can check, after going to a shopping mall, you found that all the vehicles are already filled in the spot, in the parking. It's a time waste for us. So in smart parking system, mobile only we can check where the availability is there for smart parking, for parking the vehicle. IoT applications in industrial automation. So industrial automation means in deliveries also, we can track our delivery, whatever the orders we give in any e-commerce sites. So how we can track our ID by using some RFID tags we use in this. So we can track wherever our product is delivered and reached. So we'll get a notifications on based on the deviations in delivery plans in digital factories for for improving some line of commands in the work units. In food supply chains, monitors near the real time throughout the supply chains. Like we there is a food supply when the food is supplied from one place to another place. Like in industries, there is a exchanging of the goods from one place to another place. At that process, there may be a like any whenever the rain is falling, the food may be affected. So they will inform us, like using this food supply chains we use this. So in manufacturing purpose also, food product quality testing in various stages of manufacturing cycle, in packaging the optimizations. So how this is like every product has some quantity and quality. So in industries, to monitor some quality and quantity without humans cannot do it. They are using some sensors and some devices. We can know the quality by using IoT application in packaging the food quantity. All these are the different applications used in IoT in industrial automation. IoT applications in agriculture. So in agriculture, how we use this IoT? Some sensors and actuators, some control and switchgear. These are the mechanical. So in agriculture, we relate IoT with some embedded systems. So some sensors, what are the sensors we're using in agriculture, right? Use moisture sensor, some DHT level sensor, some water quality, some irrigation systems are use some sensors. So whatever the sensors they are using in the agricultures, the whatever data received by the sensor is uploaded to the some controller, is the data given to the controller. This controller will give the application, the whatever the data is stored in the controller is given to the IoT in the cloud. So it is automatically uploaded to the cloud, so you can monitor the data. So actuators are nothing but the some mechanical outputs like servo motors, DC motors. All this comes under actuators. We have hydraulic actuators, pneumatic actuators. These actuators will convert the electrical energy into mechanical energy. So switchgear is nothing but it acts like a relay. Relay is like a on and off switch. Some controlling unit. Like you give in a smart agriculture, whenever the water quality is less in the soil, automatically the water pump will be on by using this switchgear, on and off conditions. We can also connect smartphone Android app. You can control the this you can control, you can get the updates on Android phone by using GSM feature, and you can display the values sensor updating. You can see the values in display. So this is all about the IoT. So whatever the IoT applications you take, that is connected from the embedded systems. Though this IoT and embedded systems are related, so you can know some basics of embedded system. So anyone have an idea of embedded systems? Okay. So what is embedded system? Generally, what is a system first? So I know what is a system. So system is nothing but all the units assembled together to do some specific task. To perform some specific task is called as a system. Embedded system means what? It's a combination of software and hardware. Specific task. Perform some specific task is called as a system. Embedded system is a combination of software and hardware. Yeah. So it's a combination of software and hardware. So using some mechanical components to do some specific task. So in embedded systems consists of a microcontroller with onboard memory, a power supply, and some communication ports for transmitting the data to other devices. These communication ports are nothing but UART protocols, some protocols we use to send the data to the devices. So we have in embedded we have hardware and software combination. So embedded software programs tells the microcontroller like the program we write in the embedded software. We use embedded C in Arduino IDE. So the what are the code we write, the software program we write, it will tell the microcontroller how to respond in real time. So whatever the code we dump to this microcontroller, it will ready to real time to it will collect the data from the environment, like how to respond in real time to data collect from the environment to verify the sensors and devices. So these embedded systems also used in all our household applications, industrial purpose. This, embedded systems are nothing but software and hardware combination. So whatever the electronic devices you see, these all are the embedded systems. So any electronic device works on the processors and controllers. So these embedded systems in the main we use embedded systems is controllers and processors. Some memory units, some Arduino based node MCUs. All these are related with the embedded systems. This is the embedded system, like how this is a process. This is some basic block diagram. So the sensors, whatever the data is collected from the environment is given to some hardwired unit, like it may be timers, some A by D converters, D by A converters. A by D means analog to digital converters or digital to analog converters. Some hardwired unit we have. We can externally connect some memory, some CPU, some actuators, and this all is the embedded system. The hardware unit may be microprocessor or microcontroller, some CPU and controller, some memory we part. This picture says how the embedded system works. So in embedded we have know some what is the inputs and what are the output units. So generally embedded system we deal with sensors. So you have an idea of sensors? What is sensor? So sensor is a device that measures so it sends the input, whatever the input you give from the environment, it sends the input. So it collects the data from the physical environment and that converts the data into some electrical signal. So sensors are nothing but which sends the inputs. Sensors all acts as the inputs. So we have different sensors like a temperature sensor, accelerometer. Accelerometer is also a sensor used to sense the speed of the motor, or in vehicles also speed of the motor we use accelerometer. Infrared sensor, IR sensor, ultrasound sensor, touch sensor like a biometric, color sensor, smoke sensor, humidity sensor. All these are the different types of sensors which are used to collect the information from the physical environment. So in temperature sensors you take, we have two types of sensors, like contact sensors and non-contact sensors. So contact sensors are nothing but temperature sensor you can take. For example, in temperature, like thermometers, we contact with body. Whenever we touch, whenever they contact with the body, they will know, we can know the temperature of the body by using thermometers. This is a contact temperature. Whenever physically interact only, we can know the temperature of the our body with thermometer. You also have non-contact temperature sensors. Without contacting, we can know the temperature of the person by using accelerometers. It's all for speed of the motors. We use this. So it's all the sensors will collect the information or data from the environment, physical environment. Accutators. So accutator is nothing but some loads, like outputs we give, like LED, whatever the accutators, like DC motor, servo motors, some different motors we use now, that all comes under accutators. They convert this electrical energy into this mechanical energy. So they use this for, a form of power to convert a controlling signal into a mechanical motion. So these all are the examples. We are given rotatory accutators. We have a linear accutator, circular accutator. Rotatory accutator means they move in a circular motion. Some round body accutators. These all are the mechanical components. So embedded system is software and hardware. So using some accutators, mechanical components. These all are the some outputs units, accutators. So these are the steps to follow for collecting the data. First, communicating the devices using internet. So connecting to the first communicate the device, and we connect to the device we are using first, and data storage purpose, and then sensing and collecting data from the environment, nature. Then we are analyzing the data. These are the steps to follow. These are simple steps in IoT. Okay, so what are the levels of communication? Like collection, communicate, and analyze, act. So these are the different layers in things, like perception layer, network or transport layer, application layer, and care providers. Things and fog computing, cloud computing, and these are the applications like ERP, CRM, SCM. These are the different applications. These are the computing techniques in IoT. So what is a microcontroller unit? So my microcontroller unit is nothing but it has a memory and decoder and encoders. Some control unit, execution unit it has to follow some instructions. It's like a microcontroller. So this is the architecture of microcontroller. So how we use this microcontroller unit for IoT? For simplicity. So in most IoT use cases, the relative simplicity of MC is an advantage. So this MC is mostly an advantage for IoC. They not required so many operating systems to function. They are having very less instructions, microcontroller units. They are very easy to interface with the external devices. So they are easy to connect with the devices you give, or sensors and motors. These microcontroller units are very easy to collect the data from the sensors and actuators. Additionally, whenever you write the coding or programming due to controller is very minimal. This very simplicity means very easy to do this process, and very secure also. So security means by virtue of the relative simplicity. So MCUs offer very few, there is a less attacks of these MCUs. So the whatever the code we dump on the microcontrollers, it will be runs on the bare metal, a metal surface. You execute the code. So there is no use of some operating systems to execute. There is no directly we can use some Node MCU. There is no need of using some operating systems. Whereas you take Raspberry Pi, like that Raspberry Pi, we have to use operating system in that. But in in these microcontrollers, there is no need of using downloading again operating systems. So there is a less chance for attack vectors. Cost. This cost also very reasonable. In most contemporary IoT applications, MCU can deliver all the processing power and functionality one needs. So as a result, MCUs are the most often the best. So this MCUs microcontroller units are very best and very economical price, and is a good choice for the IoT applications. Overall, they are simple, secure, and very little cost. So you can go very deeply. What is a microcontroller? So microcontroller is a computer system. It's a full computer system. You can say it's a full computer system on a single chip. A very small chip is there, where it's same like a computer. So this is designed for stand-alone application operations. Stand-alone operations like some independent functions without requirement of other functions. We can. It is independent. The single chip is used for operations. So what is difference between microcontrollers and microprocessors? Anybody? What is the difference between microcontrollers and microprocessors? So microcontroller, I said now. In microcontroller, already a CPU, some microprocessor is inbuilt in it. Input, output ports, ADCs, RAM and ROM, some serial COM port, timer, phase lock loop. All all these are already inbuilt in the microcontroller. Whereas a microprocessor is a multitasking one. It is like a general purpose microprocessor. It acts like a CPU. It's like a single chip, acts like a CPU. We externally add the RAM, ROM, input, output ports, some timer and serial COM ports. We externally add this to the microprocessor. In microcontroller, we no need to add the external peripherals to it. We can already, it's an inbuilt system. Okay. And microcontroller has very less instructions as compared to microprocessor. So, but a microprocessor can't do all the functions of a computer on its own. So compared to the computer system, microprocessor can't do all the functions as a computer system, but it needs another circuits because computer does all the systems on its own. Like it has some memories, CPU support, external support it has, but processor has no. Microprocessor even in multitasking, it needs some external support. Like it should add external peripherals to it. Circuit you should add like input devices, RAM, ROM, some DMA controllers, timers, phase lock loops, analog to digital converters, LCD drivers, etc. Whatever the ports we have to externally add to the microprocessors. So this is the general comparison. We are comparing microcontroller and microprocessor. So microcontroller, the main purpose, what is a microcontroller is? Microcontroller is only used to do specific task. It will do only one task, only some specific task only it will do. Whereas microprocessor will do multitasking. Microprocessor used for multitasking. Like example is mobile phone. So microprocessor example is mobile phones. So microprocessor is a multitasking one. We have to depend mainly on some other devices. Microcontroller already is inbuilt one. So use it for a few dedicated functions determined by the system designer. So it is a microcontroller is from the user end we cannot change. It is also used in many applications. So we can according to the program we given to it. So microcontrollers used in the large systems and microprocessor also used in all the multitasking purposes, it is the heart of the PCs. This microcontroller is heart of the embedded systems. We can know very deeply some about the briefly about the microcontroller. So microcontroller has a processor. You can see this diagram, you can easily understand how the microcontroller works. So already some many peripheral indicators with this chip like flash memory, RAM, input ports. These are the input ports of the microcontroller. A microcontroller has some timer module to do some certain to perform the task with a given time. So it has some input port to allow the data between the microcontroller and other devices such as PC, serial communication purpose, and the analog to digital converter also there in MCU to accept the analog inputs for the processing. This is the history of the processors. Who invented in which year? Like in 1971, some Gary Boone and Michael Cochrane was invented in 1977. These are the companies. So these are some popular companies of microcontrollers. Intel and other 8051 microcontroller, 80386 Intel, PIC microchip, Motorola, Zilog, Z8, Z3, like the different microcontrollers of companies. So these are the hardware development. Means this is about choosing a correct microcontroller for your application so that you can satisfy the required specifications. The criteria for choosing a good microcontroller. How to choose a microcontroller? So it should have a number of input ports. It should have good ports, more ports it should be available, and it should support the serial communication module. It should have some external peripherals for timing circuits, some ADC and pulse width modulations, and some memory requirements. It should support some more memory required, more storage, and the processing speed are required. The speed of the processing should be more. The process should be as good speed, and some power requirements, some voltage purpose, some power requirements also. You should have good power. All these are the specifications of a microcontroller. The microprocessors. So is a block diagram of microprocessor. A processor consists of a ALU, control unit, and register array. ALU is a arithmetic logical unit. It is used to do some calculations like arithmetic operations. ALU is used for multiplication, division, subtraction. All these operations ALU is used, and it has a control unit and execution unit to control the instructions and to execute it. A register array. We have some different shift registers, counters, all these registers. So microprocessor already this all will consists, and we externally add input device and output device, and we connect we give some memory unit to the processor. These are the basic terms of processes. So in embedded system we use some different processors like Arduino, Node MCU. So we can learn some Node MCU about some Node MCU, how we use in projects. So this is a pin configuration of Node MCU. Generally Node MCU is a microcontroller. It is an open source one. It is a hardware Node MCU. Node MCU is a Wi-Fi module. For Wi-Fi module purpose we use Node MCU. This is a pin description of Node MCU. This is a V in ground. We have this general purpose input output pins. From 1 to 16 we have general purpose input output pins. So we have one analog pin ADC naught. A naught is only the one pin available on Node MCU for connecting analog signals. Analog inputs. So this for digital inputs only, digital input and output purpose, we use this general purpose input pins. And this RX and TX is there now. For this is for receiving and transmitting the data from like different wireless networks like Zigbee, LoRaWAN. All these wireless networks purpose we use this RX and TX for communication between the two devices. Like we have three protocols: the UART protocol, SPI protocol, I2C protocol. These three protocols were used for communication. We use UART for universal asynchronous receiver and transmitter for bus communication purpose. These are communication systems with RX and TX pins. And this MOSI, CI, MISO, SL clock. CS is the data pin. This clock pin, all these four pins are for the SPI protocol. So this NodeMCU is mainly used for the IoT platform. So it's the open source IoT platform. It includes some firmware which runs on the ESP8266 Wi-Fi SoC. So these are some specification of NodeMCU, who developed it, and some what is the operating system it has, CPU, what is the processor using. The NodeMCU ESP8266 is a processor, CPU. We are using the NodeMCU ESP8266 processor we are using. It has 128K bytes memory and 4 ampere storage. Power we use for connecting, for giving the power use, you connect with the USB to the CPU. So till now we have I hope you have an idea of hardware. I mean, whatever the process and controls we use in the embedded systems, some sensors and actuators, you have got an idea about it. Like, I hope everyone understand till now, right? So, and now time is 1 hour is completed. So remaining 1 hour, we can do some hands-on session for weather mountain system. Okay. So before going to the hands-on session, we can also know Arduino IDE software. So Arduino with IDE. Arduino IDE software is we have Arduino hardware. We use Arduino IDE software for whatever the code we write in this Arduino IDE. So simply how to, it is very easy to download this Arduino IDE. Go to Google and type Arduino IDE install. You'll get a version like a you'll get an option like Windows or Mac OS. You can download simply. So I'll show the step by step. So whatever the code we write in the Arduino IDE will be uploaded to the NodeMCU board, NodeMCU chip. I should previously explain, So the Arduino IDE is a software program. It is an open source protocol. It runs on all the operating systems like Windows, Linux, Mac OS. All these operating systems we can run the Arduino IDE software. It is open source, and you can also do some modifications in this. So whatever the code we write in the Arduino is called as a sketch. So these three things we have to keep in mind, like global variables, setup functions, loop functions. Global variables are nothing but the declaring the variables at the top. First we declare the variable, whatever the variable, like integer, float function, like that we declare the variable in the Arduino sketch, Arduino software. So these are some basics of writing the code in Arduino. In Arduino we generally use C language, embedded C are using in Arduino. So global variables, like in further we write the code, now you can understand it. So declaring the variables, first we have to declare the variable. What is the variable you're using? Int function, float function, like that. So in setup function, we initialize the pins we are using. So whatever we write in the setup function is only run one time. It only runs one, and we are describing the pin connections and pin mode where we connect the pin. Running in loop function, we run repeatedly after some setup. After some setup, we run the repeatedly after setup. Loop is an automatic format, repeating and repeating. This in the run in this whatever we write in the loop are the Set up functions like how to work the sensors, working and reading and working purpose from analog and digital sensors, whatever it may be. For working purpose, we use this running loop. So what are the global variables when done? Like integer LED pin equal to 13. Okay, in Arduino, first we have to declare the variables. First, whatever the code is start now, we declare the variable. So using integer is some variable. We are using LED pin description. LED is connected to the pin number 13. So LED is connected to the control pin 13. Int A sensor. A sensor is connected to the 0, pin number 0, D0 or A0. Analog pin A0 we are connecting. Int state pin, like a pin is low or high, use this to hold the state of a pin. These are some variables. Arduino sketch. In Arduino sketch we have a pin mode. I said you have set a pin as input or output. What is a pin mode? Like pin comma output or input. We are knowing that pin is input or output. Some pin numbers we for this function we use this pin mode. Serial dot begin. Serial dot begin is used for baud rate. The number we give is some constant baud rate. So serial dot begin to the computed baud rate. Okay. These all are the some loop functions. Repeating purpose. Digital write or read working purpose or reading, taking the collecting purpose. Collecting or receiving data. So writing digital read means analog signals input. We are reading the data. Write means working purpose. Output purpose. This write function we use. Delay we use some milliseconds we use delay amount. How much time it will delay we use for waiting an amount of time. So this is about some again programming environment. Like Arduino Uno can be programmed with Arduino software. We can also connect controller to it. These are the different about some Arduino software. So whenever after downloading, you can also use this link, or you can download the Arduino IDE. You'll get an option when you type in Google like Arduino IDE install. You can directly you can use this link, or else you can simply type Arduino IDE install in Google. You'll get the options. Go to downloads. So after simply going to downloads, you get an option to download. After downloading, in your page, in your library page, you can see a simple application like Arduino. Okay. After downloading, you get an application like Arduino. After clicking on it, the page will open like this. Arduino sketch page will open like this. There you will find a cursor. You will find on the toolbox. You will find file, edit, sketch, tools, help. All this. So you can see here tick button. This is used to verify the code and compile and save the code. I will explain you in the next hands-on session. This is about simple connections of LED. So already have an idea of sensors, right? So a sensor is nothing but the device that measures a physical quantity, like converts into a signal, electrical signal, which can be very easy to read by the observer or any microcontroller. So these all are the examples of sensors: water level sensor, LDR sensor, analog sound sensor, electricity sensor. These are current sensor. These are all the sensors, different types of sensors. Okay. Now we can know some sensors and specifications. IR sensor. So IR sensor is a simple electronic device like which emits and detects the IR radiation. To like this IR sensor used to detect any obstacles or objects, whatever the object is there in front of it, it will detect it by using infrared waves. So we are using IR rays to detect the object. Like it will detect using some heat and motion sensing. Any heat is there, any motion, any movement also it will detect. You can see a blue color here, like it is a potentiometer, like for existing the distance, range of the distance, use this. We have two LED lights in the IR sensor. This IR, we are having two LED lights here, like one is for power indication and another is for output display. So whenever we connect the IR sensor, we get the IR is working, we'll get a power indication, and whenever object is detected, we'll get an output display, like it will LED will glow on the IR sensor. This is a fire sensor. IR sensor and fire sensor look similar, but there is a in fire sensor only black color is there. This fire sensor also works on IR rays. This is like is used to detect the fire. Okay. This is a pulse sensor for knowing the heart rate, your movement of blood in your body. Pulse sensor used for heart rate, checking your pulse. So, this how this pulse sensor applications in daily life. So while we're doing exercising or studying, wherever you are, you want to know your heart rate, you want to check your pulse. To overcome these sensors, we use these pulse sensors. This is very easy, just simply connecting this pulse sensor to an Arduino board, which may be used for some many students, all the project type developers. They utilize this heartbeat information in the projects. This is a LDR sensor, is a light dependent resistor sensor. This light dependent resistor sensor will be used for in the power consumption, power saving street lights. These are the different applications of LDR sensors. So automatic street light systems detect the day or night. Like in street light systems, whenever it is a day, the LDR sensor automatically off the street lights. Whenever it is night, it will be high. It will on the street lights. Like that, for power saving purpose, we use this. So as our topic IoT, so what in IoT we is nothing but for storing some cloud data. Like IoT is a cloud purpose. So storing some data of the sensors, we use some different cloud platforms. ThinkSpeak, Video, like different platforms are there for storing the sensor data. So about you have an idea of ThinkSpeak? So ThinkSpeak is an IoT application. It's a platform service that allows you to aggregate and visualize and analyze the live data in the streams in the cloud platform. So whatever the data you collect from the sensors is stored in the cloud, and you can automatically visualize the data, and live data streams you can observe, you can see in this cloud. So previously I explained you NodeMCU, right? So the NodeMCU is a Wi-Fi module. It's an IoT platform. NodeMCU used for the IoT projects. This simply we connect some sensors to the NodeMCU, and we perform this. So we can do some hands-on session. We can do some real-time application, like we can have some weather mounting system. Simply we can do some small project here, like weather mounting system to know the weather conditions, like temperature and humidity. We are using a DHT11 sensor. DHT11 used to sense the humidity, like from and gives 80% accuracy of the humidity, and temperature like 0 to 50 degrees. It will support, the sensor will support. So DHT11 sensor is used for the weather mounting systems. So this is a ThinkSpeak platform. We can monitor the DHT level values. So this is a gas sensor. Gas sensor used to detect the poisonous gases in the industries. This is a real-time application in industries. In in aquaculture also uses gas sensor for knowing the any gas, poisonous gases were released. For methane, butane, like the different types of gases it will detect. So these are used to detect any presence of dangerous LPG leakage in your car or any service stations, petrol bunks, some storage tank environments. Wherever is any emergency, like wherever some working with the fuels, it will give an alarm input to you whenever a gas is detected. It it will give us alarm sound. So they have an excellent sensitivity to sense any gas and give a quick response in a time. The sensors can also sense isobutane, propane, LNG and cigarette smoke. This is a DHT11 sensor. So now we can do some real-time application using some DHT11 sensor here. So DHT11 sensor has 3 pins. One ground pin, VCC pin, another it's a data pin. So we can take data pin as a digital pin, we can connect it to digital pin or else analog pin. So DHT sensor used for knowing the temperature and humidity you can use for weather purpose. You can also use in smart health applications also. So it is available with a sensor type or else you can also buy it as a module. It has one resistor and pull up LED. Okay, to measure the surrounding air in the sensors. This MEMS sensor used for the position tracking. Okay, for knowing the left right like position purpose we use MEMS sensor. So we can write some programming of weather reporting. Okay, so you can do some hands-on session. Everyone ready? So you can now we are writing some code in Arduino IDE. Some hardware setup I will show you. So this is Arduino IDE software. You have to create a new file in this. So when you go to the boards, so I will show how to download Arduino software. You can write some code here. everyone wait for 5 minutes. I will write the code and I will show you some real-time example of weather monitoring. Maybe search చేసాను. Oh, this one. This is not So today we can write the code for the weather monitoring system for DHT11 code. I will explain you the code of every single line. So in simply we are using two gas DHT level sensor and node MCU. So first we have whatever the hashtags I have given, right? Hash includes header library file. These are for the library functions we have downloaded. Okay. So first we have to software serial.h. This is for the software using like for TeamSpeak platform web services. DHT, you have to download the DHT level library, wire connections, and this is for the ESP8266. When you go to the option tools, you will get a option board. In this you have to select the ESP8266. Okay, so whatever you write first for DHT11 and this ESP82, you have to download the library functions. So you have an option here. When you go to the files, you can get some examples like this. So these all are the, when you want some codes also, you can simply look on this examples you'll get. So we have to download some these hashtags are all for the already downloaded libraries. Okay, so hash define DHT pin 6. I have connected this digital we have 3 pins in DHT11 sensor. I will also show the hardware setup at the end of this code. For we have to connect we have 3 pins in DHT. First is ground and second one power supply, third one is data pin. We are connecting this data pin to the digital sensor digital pin 6. Okay, so float A int we are using the float here. Float means generally we use variables, we have integer float. For float is used for the temperature values, some values we are getting from the environment, analog signals. So we use float here, float variable, float a, and integer is pulse. You are using pulse, and so for all you can use this. So now we are doing weather project, right? This is about the connections. First we use a library function ESP8 we have to download. Then we have to download the library function of DHT1. We are connecting to D7 pin. This is all about the Wi-Fi connection. Whatever the server you are taking, TeamSpeak. First we have to define the whatever the cloud platform you are using. I am using the teamspeak.com. Okay. Now you get an option. All are the libraries. Okay. This constant care you have an my SSID. This is a social network. Whatever the network I am using, it name. This is a password you are using. And Wi-Fi client. This is for the Wi-Fi connections. So there is an option TS server. I am using the api.teamspeak.com. This is a server name. Okay, now it is clear for everyone. You can see the code, right? Previously it is very slow. You can see the code.
class అయిపోయిందా
Please wait for 2 minutes. This కొంచెం దాంట్లో కోడ్
స్క్రీన్ అన్లాక్ చేయాలంట
అదే ఆ స్క్రీన్ పెద్ద
Attendance Google reviews.
Okay. This is the hardware connection of the DHT11 sensor to the node MCU. So we are uploading this data to the cloud IoT ThinkSpeak platform. Okay, so now everyone is able to see the code clearly, right? So first we have defining the ThinkSpeak platform you're using. What are the server you're using? These all are the header files. So we are downloading the library for the Wi-Fi ESP8266 Wi-Fi and ODMs you are using. We have to download this library. Then some Wi-Fi client secure. So this also have to download, and we have to download the DHT11 library. This hash include define all these other library functions we are using. So we are connecting the DHT pin D7 data pin to the digital pin 7 D7. So this is a Wi-Fi connections. What are the system, whatever the network you're using, we write your name. You can write any name. I'm using social network. This is my SSID. Okay, my password. So constant char. My password is, this is my password. This is some Wi-Fi client connections. This all are the serial.print. This is the printing lines. Whenever your Wi-Fi is connected to this node MCU, these are the printing lines of that. Wi-Fi.begin, Wi-Fi status. This is the delay time. These all are the Wi-Fi connected. You will get these all things. Okay. This is the starting of the connection. All are the printing lines only. Wi-Fi connected is all this. Now whatever you write in the void setup, in void setup you write the pin mode connections. And buzzer is, you can take a buzzer as a output. Whenever there is a temperature is high, we'll get a buzzer output. So these are the connecting Wi-Fi. We are seeing this output data in the IoT. Okay, so this is a connecting Wi-Fi connection setup code. Serial.begin. The serial.begin is a baud rate 9600 constant baud rate we are using. Baud rate is nothing but the speed of the bits, bytes transformed. This void loop. In void loop is a repeating function. Working principle we write here. So float function, we get the values in a decimal way. So we use the float variable. DHT.read humidity and DHT.read temperature. So DHT sensor used to read humidity and temperature. We get the values in a decimal way, so we use the variable name float. So this all the lines, any check if any reader fails or exits. This all the lines we give, it will also inform that like whenever we DHT level is connected, we get these lines like temperature values and humidity values. Whenever it is disconnected or any problem in the DHT sensor, we will get the line, printing line like fail to read from DHT sensor. Again return statement we give here. So whenever the sensor is unable to read the values, we get this statement. Okay. So this is in the Fahrenheit scale values. Float HIF is equals to DHT computer heat index. Like true or false condition type. So first serial dot print humidity. So first we are giving serial dot print humidity. Print dot H also we are giving another line, printing line. We are giving delay 1000. 1000 means here 1 millisecond. So we are giving some threshold value like 45. We are giving, can give any value. So we can have every humidity has some threshold value. So we are taking threshold value as 45 here. So humidity is, if H is greater than 45, humidity is greater than 45, then we write the digital write as buzzer comma high. The buzzer will give a beep sound here when the humidity crosses the threshold value. Or else the buzzer is low. The buzzer will be low. Okay. Same applies to temperature also. When the temperature crosses the more than 30 degrees, then we get buzzer will be indicated, or else buzzer will be low. You have to give the delay time for both 1000 and 1000 like this. So whatever the use if and else statements here. So this connections, if statement and these connections for client server connections. This is for using TeamSpeak platform. That for server connections, this is string post str. TS API key. This is for key format connections. So we have here post str plus is equals to field 1 string t and field 2 string h. Why we given field 1 and field 2 is this is for the sensor values, like field 1 for temperature and field 1 for humidity and field 2 for temperature. Okay. This is all about the connections, Wi-Fi connection. These are the client, printing lines for client. Okay. Like TeamSpeak platform, server connections, this all are. We are giving the delay 1000. And we have to end with the line client dot stop. Okay. This is about the code. Now I will verify it and compile the code to my board. So we have verified the code and we have uploading this. We have uploaded the code to the Node MCU. So you can see a button done compiling. After compiling, we have to go to the serial monitor. So you can see the values of temperature and humidity here. So you can see the changes in the temperature and humidity. So we can see the output in the serial monitor of this. Now we can see the output in the ThinkSpeak platform. Okay, IoT. Uh,
అవినాష్ చెప్పండి సార్ ఇంటర్వ్యూ అవినాష్ ఇంటర్వ్యూ అని చెప్పండి.
so this is my ThinkSpeak account. So this is my ThinkSpeak account. So you can simply create the ThinkSpeak account by giving your mail ID and phone number, all this, your name and email ID. After creating ThinkSpeak account, you have an option here, channel options. So you can go to my channels. So now I have created some channel like weather monitoring system. So now we have done a project of weather monitoring system. Now we have to know the values of temperature and humidity. So in field 1 chart I created the temperature and field 2 I have given the humidity. So these are the temperature changes till now. With the date and time you can clearly see how much by second how much it is changing. See our temperature and humidity. So I can go to so this is my API key. So everyone has their own API key for the account. So we have to copy this key and we have to put in the code. We have write API key and read API key. Both keys we have. We have to use write API key. We have to use